Okay, let's continue our discussion of number systems from the previous video. And we're going to talk about hexadecimal number systems. So if you remember the previous video, talked about base 10, well, base 10, base 2, but we said that all number systems begin with 0. You can see that with base 10 and base 2. Each number system, depending on the number system, that's how many digits we have in the number system. So base 10 has 10 digits. We say that 0 through 9. And base 2 has 2 digits. Well, just 0 and 1. Base 16 also starts with 0, first digit, and then it has 16 digits. We're going to see that 0 all the way to F. Let's take a look at how we got there. Okay, excuse me. So hex, we can borrow the first 10 or use the same 10 digits that we use in decimals, 0 through 9. Now we got to come up with another 6 symbols. Now we could use hashtag, exclamation mark. They could have come up with something, but they came up with something much better. Let's use a sequence of symbols that we already are familiar with, like the alphabet. So A, B, C, D, E, and F. So what this means, by the way, is if you are 2 years old in decimal, you're 2 years old in hexadecimal, base 16. 7 years old in decimal, you're 7 years old in hex. 9 years old in decimal, 9 years old in hex. If you are 10 years old in decimal, you are A years old in hex. Same value, just different way to represent it. Okay, if you are 11 years old, you're in decimal, you're 12 years old in hex, etc. All the way to 15 years old, you are F years old in hex. So let's take another look at this. So we said that if you are 9 years old in decimal, you are 9 years old in hex. Okay. If you are right here, if you are 10 years old in decimal, you are A years old in hex. Same value. Okay. Let's keep on going. If you're 14 years old in decimal, you are E years old in hex. If you are 15 years old in decimal, you are F years old in hex. Now, what happens if you turn 16? Remember, or we talked about this in the previous video, when you get to the end of a value of a symbol in the number system, okay, you just put a 0 here and increase the next column by 1. So the next column, the first column is column of 1s, but because we're talking base 16, the next column is column of 16s. So 1 0 in this case, because we're talking base 16, this means 1 16 and 0 1s. That equals 16 decimal. Okay, let's take a look at some other ones. All right, and if you're following along with the homework, here's that number right up here. All right, so if I am, let's go from hexadecimal to decimal. Okay, so this is the column of 1s here, column of 16s. 6 1s. And we could put a 0 here, right? Okay, that's the same as if we didn't have anything, if we left it blank. All right, 6 1s. Well, that's just 6 decimal. Okay, as we can see here, 6 1s is 6 decimal is 6 hexadecimal. Okay, all we're doing is taking 6 times 1 is 6. Okay. Well, we can also look at this kind of like currency. We've done that before in the previous video. So let's take a look at this. If I gave you a $1 bills, how much am I really giving you? I'm saying it's A. Okay, well, A is 10 decimal. So what I'm giving you is 10 $1 bills. Okay, or 10 times 1, 10 decimal. Okay, this is just the column of 1s. What if I did this? What if I gave you now 1 $16 bill and 3 $1 bills? Now, what can go in each one of these columns is anything from 0 hex to F hex. That's what can go in any one of these columns, just like our other number systems. Okay, let's start here. If I gave you 3 1s, what would I be giving you? Okay, I'd be giving you 3 times 1 or 3. Okay, and I'm going to give you 1/16. So what would I be giving you? 1/16 or 16. Well, just add those together. 16 plus 3, okay, is 19 decimal. How about this one? Okay, A0. Let's start on the far right. Okay, could start either way, doesn't matter, but we're going to do 0 ones. Well, 0 ones is fairly straightforward. That's 0, no ones. A16. So how many 16s am I giving you? You're right. A is 10/16, right? 10 is A. So let's just take 10/16. So 10 times 16 is 160. So what am I giving you total? Just add those together and we get 160. Let's do another one. Uh-oh, BC. Okay, this is not hard. We just have to do a little arithmetic. All right, so C1s. What is C? Well, C is 12. So 12 ones. 12 times 1 is 12. B, 16s. Let's find B. B is 11. So 11/16. 11 times 16, get that calculator out. 176. We just add these together and we get 188. 188. Okay, this is a true story. My mom, when she was with us, she had a birthday. And I got her birthday card, said, happy birthday, happy 50th birthday, Mom. And she got the card and she goes, oh, well, thank you, but I haven't been 50 for quite a while. And I said, Mom, that's 50 base 16. Now, my brother, the physicist, he thought it was funny. My brother, the nurse, he didn't get it, but you'll get it. All right, so what are we doing? I said, Mom, this is base 16. Okay, what does that mean? Okay, what this means is this. 0 ones. How many ones? 0 ones, so that's 0. The 5 is how many 16s? So 5 times 16 is 80. Yes, this was my mom's 80th birthday. Okay, so I told her, Mom, you don't have to get older. You just have to change number systems. All right, let's take a look at this one. Let's go from decimal now to hexadecimal. Okay, what if I have decimal 9? Okay, let's say I owe you $9. Can I give you any $16 bills? I'm not going to give you any $16 bills. Okay, I'm going to owe you $9. I can give you how many $1 bills? I can give you, so I'm going to give you 0/16s and I'll give you 9 $1 bills. Okay, so now give you 9 $1 bills. 9 minus 9 is 0. I don't owe you any more money. So 9 decimals is the same as 9 hexadecimal. Now, what if I owe you $10? Well, I'm not going to give you any $16 bills. Again, I can give you anywhere from 0 to F, 0 to 15 of them. Okay, I'm not going to give you any though, because I don't owe you $16. I only owe you $10. So how many am I going to give you in hex? Remember, we're doing this in hex. Got to put a hex value over here. What's 10 in hex? You've got it. That's A. All right, so 10 minus 10, I don't owe you any more money. I'm just expressing this in base 16. Okay, what if I owe you $21? Can I give you any $16 bills? Oh, I can, huh? I can give you one $16 bill. Now, how much do I owe you if I give you $16? One $16 bill. Well, let's subtract that. I owed you $21. I gave you a $16 bill. I now owe you $5. Okay, and I can give you 5 ones. Okay, I owe you 5. I give you 5 ones. Now I don't owe you any more money. Okay, how about this one? What if I owe you $33? How many $16 bills might I give you? Oh, this case, yes, I could actually give you 2 $16 bills. Because 2 times 16 is 32. Now what do I owe you? I just gave you 2 $16 bills. Okay, subtract that from 33. I only owe you $1. So give you 1, and now we're at 0. Okay. How about this one? I owe you $50. I'm going to give you $16 bills. How many could I give you? Okay, well, one would be 16. Two would be 32. What if, could I give you three? Yes. Okay. If I gave you three $16 bills, that would be $48. Now I only owe you $2. Okay. So what am I going to give you? I'll give you two $1 bills. You also might know somebody that is turning 50. And when they do, you could wish them happy 32nd birthday in base 16. Okay. Sometimes it works this way. Yeah, you don't have to get older, just change number systems. Okay, what is 160? How many 16s can I give you? Well, this isn't too bad, right? 16. How many 16? Oh, 10. But we don't put a 10 here, right? We're using hex. So what's 10 in hex? Yep, it's A. So that's the same thing as saying 10 times 16 or 160. Now I don't owe you anything, but don't forget, put that 0 there. Whoops, went too fast. Put that 0 there. Put that 0 there. Otherwise, it will look like A1s instead of A16. 10 16s, not 10 1s. Okay, how about 170? Well, let's see. How many $16 bills can I give you? Again, I can give you 10. Okay. A $16 bills. That's 10 or 160. 10, right? A is 10. A is 10. 10 times 16 is 160. We have 10 left over. How many ones am I going to give you? Again, I'm going to give you A. A ones, 10 ones. Okay, 10 minus 10 is 0. I've given you all your money. Okay, why hexadecimal? The beauty of hexadecimal is this. We use it in computer science, computer networking. We use it in many different areas of computer technology because when we want to represent binary values, bits, okay, if I want to represent 4 bits, let's do 4 bits here. So here we have number 1s, 2s, 4s, and 8s. This is binary. Okay, so all 0. If I put a 1 here, 1 1, that's 1 hex, 1 decimal. 1 0, that's 1 2. And that's the only thing we have here. So that's the same as 2 decimal, 2 hex, etc. Okay, I can just keep on going. Like here we have 1 8 and 0 everything else. That's 8 decimal, 8 hex. Here we have 1 8 plus 1 2, that's 10. 10 decimal, A hex. Isn't this cool? Here's another one. 1 8 plus 1 4, that's 12 decimal, C hex. They're all the same. This is the same amount. Okay, if I give you 12 apples, base 10, C apples, base 16, or 1100 apples, base 2, it's giving you all the same number of apples. Okay, we keep on going all the way to 4 ones. So 4 ones is 8 plus 4 plus 2 plus 1. That's 15 decimal F hex. 4 zeros to 4 ones. There's 16 different unique combinations. That's it. That's why base 16 is so nice, because we can represent any single 4 bits, any unique 4 bits as a single hexadecimal value. Okay, just keep on going here. Any 4 bits can be represented by a single hexadecimal value. So it's a lot easier sometimes when there's something in binary to have it displayed or written in, instead of using bunch of zeros and ones, you take each 4 bits and we represent it as one hexadecimal value. It's much easier to read. Now, if you're in my networking classes, you'll see some examples of this, both with Ethernet MAC addresses and IPv6 addresses. If you don't know what I'm talking about, don't worry. In my networking class, we'll talk about that stuff later. But let me show you a little example. Okay. Many times we like to show things in 8 bits here. So let's say we have 8 bits. And what I'm going to do here is take 8 bits. And here's the first 4. And what I'm going to actually, let me just write this all out like this for now. There we go. So what I've just done here is I have 8 bits. Here's the first 4 bits. Okay. Now don't worry about these numbers here. We're going to make it real simple. We have our little chart up here. I'm just going to find those 4 zeros and find what the equivalent is in hex. Yep. It's a 0. Okay. Now, what I'm going to do for this next one is just take these next 4 bits and find its equivalent in hex. And that's a C. So if you're looking at something on the computer, again, don't worry about this, but we talk about this in my networking classes. We don't want to see 00001100. It's a lot easier if we just see 0C. And we know that each one of these hexadecimal digits actually represents 4 bits. Like this C here is representing these 4 bits. That, keep the colors here, this single hexadecimal digit's representing these 4 bits. That's all. And it all works out mathematically, but I won't get into that. All right, let's do another one here. All right, so this one here, I'm just going to show you the whole thing here. Let's take a look at this. All right, so let's take a look. And why am I doing it in 4 bits and 4 bits, or why am I showing a total of 8 bits? A lot of times we look at things in 8 bits. I won't go into that. And sometimes it's a byte, but not always. But that's how we usually break things up. 8 bits is a byte, sometimes also known as an octet. Don't worry about that. But it's very common to break everything up into these 8 bits like this. All right, but we're going to just take these first 4 bits here. What do we have here? 1101. Let's find 1101 here, right there. What is that? That's a D. Okay, so I'm going to just take this, and in hexadecimal, I'm just going to put a D right there. Isn't this easy? Especially when you make this little chart here. Okay, next, let's take a look at these next 4 bits. Okay, and 1000, where's that? Oh, here it is. And what is that in hex? It's an 8. So let's just take that, and we have that. So when we see D8, what we're looking at is actually 1101, there's the D, and 81000. It's just easier to read, easier to write, okay? Instead of seeing a bunch of 1s and 0s, okay, all over the place, unless you're like, can read the matrix type stuff. Okay. All right, just to show you a little example here. I talked about Ethernet MAC addresses. Don't worry about what this is, okay? But Ethernet network interface cards, how you connect to the wired network, Ethernet, they have what's known as a MAC address. That MAC address is a 48-bit value. So there it is right here. Look at this, okay? And you can actually display your MAC address. If you're on Windows and go to a command prompt, you can do ipconfig /all. Mac or Linux, you can do ifconfig. Okay? And it will actually display it, but it's not going to display it like this. Although these are the actual 48 bits. Remember, everything in computers, science, everything in technology, it's all bits, it's all binary. Okay, it's a lot easier to read it. Hey, let's do it in hexadecimal. That's what they do. Okay, so Ethernet MAC addresses are actually displayed in hexadecimal. Okay, so it actually uses 12 hexadecimal digits to represent all 48 bits, because every 4 bits, every 4 binary values is represented by a single hexadecimal value. There's a 2, 0010, that's 2 hex. 0001, that's 1 hex. 1100, that's C hex. 1100 is a C hex. So we can keep on going. 1011 is B, 1010 is A, etc. Okay. It's just easier to have our MAC address displayed with these hexadecimal digits than these binary numbers. Okay. It's not much easier to read this than it is this. All right. Okay. Good job. I hope that helped. And number systems, a lot more to it. I mean, you know everything you need to know. In my classes, I'll talk a little bit more about this stuff, but you've got it.